All right, hello everyone. I think we can get started. So I hope you hear me well. And today we'll be talking about how to perform reverse engineering using different AI techniques. So just before we start, I'll introduce myself briefly. My name is Martin. I'm a software consultant and architect working in a variety of domains over the years. I'm also one of the guys that helps runs the events of the Bulgarian Java user group, where we have our own big community conference called J Prime. And on 2nd of November in Auckland, in the Parnell Hotel and Conference Center, we're also organizing a small community conference called ChurConf. We've already announced the agenda. We have quite an interesting set of speakers from different areas. So most of the topics will be focused on Java and AI, and whoever is interested to attend the event, feel free to register through the website. The event is also free for students and unemployed developers. So if for some reason you cannot afford to buy a ticket for the conference, which is at a minimal cost, just let us know, drop us an email, and we'll register you for the event. So looking forward to see as many of you on 2nd of November in Auckland. Now, in this session, we'll discuss briefly. First, we'll start covering what does the area of reverse engineering cover, and then we'll see how we can leverage AI techniques to perform reverse engineering in a more prompt manner that simplifies our jobs. We'll also look at some tools for AI-driven reverse engineering and discuss briefly what's the future of AI-driven reverse engineering. So, reverse engineering, as most of you know, has broad meaning. It does not boil down only to certain scenarios. So, in one aspect, reverse engineering is related to the understanding of how a legacy system works. In many cases, we start on a new project, not only Java. It might be Node.js project, might be some other programming language, and there is a decent amount of source code being written. So one of the goals we have is to understand how all of this source code works, what are the links between the components of the system, what libraries are being used, and so on and so forth. So in one aspect, we need to understand how a legacy system works. If we start going more at the lower level, we need to understand how a particular piece of code works. In many cases, we see classes or methods that are quite complex, and it sometimes takes a significant amount of time to understand what does this code do, how we can maintain that code, and so on and so forth. On the other end of the aspect, reverse engineering is heavily used in the area of security analysis. So in many cases, we need to perform reverse engineering to scan, for example, for malware. In many cases, we don't have the source code of the application we would like to scan and reverse engineering. So we need additional tools that help us decompile first and then further analyze the source code of the decompiled application. And in that aspect, we also have other activities that we can do around reverse engineering here. Sometimes we may need to analyze for further vulnerabilities in our application. For that, we use different kind of techniques that we'll discuss briefly. So we have different kinds of tools for reverse engineering. For example, if we want to do malware analysis, we have decompilers for binary files like Hydra or Dare2, to name two of the most popular. If we want to analyze an already existing code base, typically we can use some kind of UML generation tools, like, for example, Spark's Enterprise Architect, to name one. There are many tools. In previous years, there were some plugins that were quite popular, like, for example, the UML integration for NetBeans that allowed us to generate UML diagrams from existing source code. To aid us in the process of code analysis, we have further tools like SonarQube, PMD, or Findbugs. Most of you probably have used them in some form. So SonarQube, for example, allows us to scan for different code smells or security issues in the code. These are the tools that I've named specifically again for Java, but based on the the stack that you use, you might have different kinds of tools for static code analysis. Also, on the other end of the aspect, we have dynamic analysis tools like, for example, Vercode or Burp that try to scan the running application for potential vulnerabilities or other kinds of issues. So these are just tools for reverse engineering that have been developed. Most of them have been developed way before we started talking so much about artificial intelligence and chatbots for that allow us to interact with the different large language models. Now let's see how artificial intelligence can aid us in the process of reverse engineering. The short term for AI-assisted reverse engineering is ARE. And it's not just a fancy term, but really a distinct area of research in artificial intelligence. This area of research tries to build large language models that are specifically trained on large amounts of code, pull requests, vulnerability databases, and documentation, and so on and so forth. And the real power of AI-assisted reverse engineering comes when it is combined with existing tools for code analysis, as we saw them in the previous slide. For that reason, we can build different pipelines, as we'll see, that allow us to combine really those existing tools with artificial intelligence techniques that further simplify the process of reverse engineering. Some examples of models that are trained specifically for code analysis are called Llama. This is one of the more popular ones from Meta. We have other models like StarCoder, WizardCoder. Other models, the ones, for example, from Anthropic or OpenAPI are particularly popular. And many of those models are used by different AI-assisted coding tools that typically we can provide in our development environments in the form of plugins or other standalone tools like even command line clients that allow us to interact with these models. And LLMs trained for code analysis, as we all understand, provide really extra added value. These models are really able to comprehend concepts from code that traditional tools typically cannot do. So many of the tools that we discussed earlier cannot simply get a piece of code and reason about it and try to find more logical explanation of what this code does, for example. Because typically those tools, for example, tools for static code analysis, they really need to parse the source code and then try to discover some relationships between the different elements in the code. And in many cases, in fact, this ability to comprehend concepts in the code that traditional tools cannot do significantly reduces the time to do manual analysis. Now let's look briefly at some tools for assisted reverse engineering. We can distinguish pretty much those tools based on two distinct categories. One of them is whether we have the source code. For example, we start on a new project and we want to analyze it, or not. For example, we have just a binary and we want to understand what that binary does. Whether we want to do malware analysis or we just want to decompile and understand how is this binary built to try to grab back the source code, maybe do some modifications, build something else. So we can distinguish those tools based on those two different categories, whether we have the source code or not. Now, if we have the source code, typically AI-assisted coding tools like Github Copilot and Claude Code provide really some nice reverse engineering capabilities like code explanation and documentation. So you can select a piece of code and you can generate some meaningful documentation. In most of the cases, it's quite good and really simplifies the reverse engineering process. We can also go with existing chatbots directly, like ChatGPT, Claude, Gemini, DeepSeek. We'll see them briefly in the demonstration that provide also code explanation and analysis capabilities that simplify the process of reverse engineering. This is how it looks like if we use coding assistants. So, for example, different coding assistants like Copilot provide typically integration for our IDEs like Eclipse, IntelliJ, or Visual Studio Code, for example. But they also provide web interfaces and command line interfaces that we can use to interact with code-centric large language models. We can go directly, as we'll see in the demonstration, with chatbots. So they are quite powerful, and we can just use the web interface of the different chatbots to do code analysis. And it's in fact quite easy. In terms of binary reverse engineering tools, as we've already mentioned, in many cases, we don't have access to the source code, and we need to use some helper tools like Hydra or Adare2 that do reverse engineering for us. So we can use one of the tools to do first to disassemble and decompile the binary into a higher level language, like typically C or C++, but this might be also another programming language, like Java, for example. And during the compilation process, essentially, we lose certain information, like, for example, function or variable names. And this means that when we decompile the binary, we don't get back that information. So we are lacking additional context, which makes the process of reverse engineering more complex. And it really makes sense to integrate binary analysis tools with AI models to provide certain activities like decompilation. So typically what we do in that case is that the large language model takes the output from the decompiler and provides more meaningful representation of the source code. It tries to deduct meaningful function names. It tries to provide code explanation. It also tries to simplify the decompiled code, which as you can guess, really simplifies the work of further analysis of that decompiled source code. How does this integration look like? So we have, in fact, a few ways to integrate those tools with the large language models. One way is by means of specific tool plugins. Like, for example, we have the R2AI plugin for Radar 2. And this plugin allows Radar 2 to interact directly with a specific large language model. So you need to have the tool, and you need to install that plugin in order to interact with a specific LLM. On the other hand, apart from plugins, we might also have MCP servers built for those tools. So nowadays, many people talk about MCP, which stands for Model Context Protocol. MCP is pretty much a de facto standard way for LLMs to interact with external tools to facilitate the process of analysis that we expect the LLM to perform. So the way this works is that we, for example, for Hydra, we have Reva as an MCP server, or for Adara, we have R2MCP. So when we provide, let's say, some binary file, like an executable file or some other format of a binary file to the LLM does not know how to decompile properly these binary files. So it calls first through the MCP server the particular tool like Hydra or Adare2, which performs the decompilation process. Then this tool returns the decompiled source code to the LLM, and the LLM further analyzes it and provides, for example, function names, simplifies the code, and so on and so forth. So in this kind of pipeline, we are able to directly integrate a large language model with a third-party tool to facilitate the process of analysis. Now, let's discuss briefly what's the future of AI-driven reverse engineering, and we'll look at how we can perform analysis on existing code. Now, several areas of improvement include, for example, improvements for large language models for code analysis, which means better training data, using more parameters for the models, and so on. We also would expect to see better usage and refinements of prompts and prompt libraries for code analysis, also provided by the different kinds of tools for AI-assisted reverse engineering. Also, more specialized tools that really tackle specific areas of the analysis of code, like, for example, dependency analysis or vulnerability analysis, and so on. Also, there are different categories of tools that have high potential for AI-driven reverse engineering tools, like code documentation. Right now, documentation really boils down to tools like code assistants and the different web-based chat agents. Different tools for malware analysis, and this is really an area of active research right now that helps malware analysts to reduce the time required to perform the necessary analysis. And another interesting area is the area of network protocol analysis. So there are different kinds of tools that emerge that try to analyze custom network protocols for potential issues, whether those are vulnerability issues or other kinds of network-specific protocol issues. Now, having said all of this, let's see how we can apply AI-driven reverse engineering in action. So for that reason, I'm going to purely use the 4 different chat models. So I have ChatGPT, Claude Code, I have Gemini, and DeepSeek. So first, when we start on a new Java project, we typically try to look at what dependencies we have in the project. It does not apply only for Java projects, but for any kind of project. So, for example, let's assume that my project uses a library like Apache PDF Box. So, Apache PDF Box is a really nice library that allows us to handle PDF files, to create and render PDF files, or to read them. Now, if I want to understand how this library works, typically what we do is go to Google or other search engine and look for certain examples or tutorials or documentation to understand how this library works. And as we can guess, this is quite a time-consuming activity. So if I try to use a prompt such as the following, as a professional software developer, so I give it the context, give me a code example of the PDF box library. Here I specify it using the Maven format with the group artifact ID and version. And let's see what this would give me. I'm going to use the same prompt in the other models, in Claude Code, Gemini, and DeepSeek. Okay, so if I go to ChatGPT, we get quite some information about the library. So first we have an example of the Maven POM dependency. Then we get a fairly simple and straightforward code example in Java. That's fine. And we also get some basic explanations. Pretty much we can expect something similar. For example, Claude Code gives us the same, a bit formatted a bit better. So the code example here is on the right side, and on the left side we have some documentation again with some details about the library and also the Maven dependency. In Gemini we have something very similar. So again, an example and description of the library. Here the main difference is in the information given about the library. And DeepSeek works a bit slower in that case, but it also gives me a few, first the dependency, then a few code examples for the library. All right, so typically if I want to build, let's say, an agent or a tool, I don't need all of that information. So I just need, let's say, a code example that I want to render. So I'll refine my prompt a bit, and I'll say at the end, please give me code example only. So let's do that. And as you can see, so ChatGPT just gives me a code example, no additional explanations or information that I need to use. If we try the same prompt in the other models, let me just paste it in Gemini, DeepSeek, and Claude Code. Okay, so yeah, it also works. So it gives me only the code example here in Claude Code, and also in Gemini we have again Let's see. Well, it gives me some more information, but yeah, this is an example with the Maven dependency. I wanted only the example, but it gives me something more. And also DeepSeek gives me, in fact, a few examples. So maybe I need to refine my prompt here a bit also to give me just one example or some specific example of certain functionality in Apache PDF box. So as you can see, you can quickly, for example, you can grab the libraries that you need some information about, like quick getting started guide, and use the chat agents to provide that information instead of going through extensive tutorials or documentation if that's not needed. Now, another powerful thing is that, as I mentioned, you can do code explanation. So here I have a version of Dijkstra's algorithm with certain issues. This is a Java class that implements the various operations on Dijkstra's algorithm. So if I go to the different models and I say, please explain this code, and I just paste the code. Okay, so ChatGPT is able to recognize that this is Dijkstra's algorithm or version of it. It gives some explanation on the different methods and what they do in that class. Okay, if we wait a bit more, node class, and it says at the end, why is this not a working algorithm? So it says that there are a few things that do not compile properly. It says that there is a typo. So that needs to be fixed in order for it to work with graphs without negative edges, and so on and so forth. So it not only explains the code, but it also tries to provide recommendations on how to improve or fix it. Now, if we do the same also in the Claude chatbot, it again recognizes this is the extra shortest path algorithm. It provides some information about the methods, what the main method is doing. It also gives you an example graph nicely that you can use to test the implementation. And it also tries to find certain problems in the code. So it's quite good as well. If you try the same in Gemini and DeepSeek, also Gemini is able to recognize its Dijkstra's algorithm again. So you can see very similar outputs. So first it recognizes the algorithm, then it gives some explanation on the methods. It provides information about the execution of the main method, and it also tries to provide some recommendation for improvements. So in fact, you can use different agents that may give you different recommendations on how to improve the code. So you can pretty much combine them to see if they can find certain issues with the code that would allow you to improve it. All right. So as you can see, you can use these chat agents for code analysis. Imagine that you, however, want to understand at a higher level how is a particular project structured. You want to see, for example, visually what's the relationship between certain components in your project. Typically, what we do, we grab a package or we combine a few packages, and we want to generate the UML diagrams from the source code, at least the class diagrams. So typically, the different chat agents like ChatGPT provide also the possibility to generate UML diagrams. And what I can do here, I'll use the following prompt. So I want to generate UML class diagram, for example, for the Elasticsearch repository. It's quite big. It has a lot of classes and logic inside. So I'm curious to see how the chat agent would handle that. Elasticsearch, if for those of you who haven't used it, is nowadays one of the most popular log aggregation engines that you can use. but it's used in practice for a number of other reasons, like, for example, a NoSQL database and so on. So let's see what ChatGPT would give us. Okay, it first says that it gives us conceptual UML class diagram, not really visual class diagram, but it's able to draw something conceptually on the core part of Elasticsearch. So we have node, which represents an Elasticsearch node. We have cluster manager that manages the cluster nodes. We have an Elasticsearch class that injects cluster manager and different services, like the indexes service used, for example, to index new documents. So it's simplistic, but it pretty much gives us an overview of how does Elasticsearch work internally. And it asks us if we want a more detailed UML diagram for a specific module, like indexing. And I can say just UML diagram for indexing, and I'll even refine it a bit. I'll say visual UML diagram for indexing. Okay, first it gives us plant UML representation. So many of the chat agents, in fact, support generation of UML diagrams using plant UML syntax. So you can just copy this code here and import it in plant UML to visualize it. And it also allows me to render this model here directly in ChatGPT. It takes some time, but while it renders it, I'll check how the other models work. So I'll also say in Cloud Chat Agent, please generate UML class diagram from Elasticsearch repository. Let's try the same with Gemini and DeepSeek. So it typically takes some time to render the diagram. It's not so fast. Now, if we while we see what ChatGPT gives us, let's look at, for example, Cloud. Okay, so it also rendered certain code. So what does it say? Let's see. Okay, so it rendered something right away. Let's see if we can zoom a bit and see what it gave us. So it's quite a detailed diagram. So Bootstrap, this is the entry point of the Elasticsearch node that starts up a new Elasticsearch node. This is the class that represents an Elasticsearch node. And it uses different services like the indices service to create an index or to delete an index in Elasticsearch. We also have cluster service that manages an Elasticsearch cluster and so on and so forth. I'll not go through the entire diagram, but as you can see, it generates UML diagram from the core part of Elasticsearch, which is quite good. So it allows us to quickly review and see what's the relationship between the different components, classes specifically in the Elasticsearch project. So that's quite good. ChatGPT is still rendering something. Okay, so here we have an example, very simple UML diagram rendered based on plant UML. As we can see, pretty much it's based on the index service. So it's a really simplified, let's say, UML diagram. But if we are more specific in our prompts, we can render really for specific areas of the code repository UML diagrams. Okay, so yeah, Gemini also tells us that generating a UML class diagram from the entire code repository is not really feasible. So it gives us some information about the base classes in the core module. All right. It didn't give us right away a UML diagram. And DeepSeek also gave us some information. So again, plant UML code for just a few classes of the UML diagram, gives us some information about the main architectural layer. So it tries to deduct some more higher level let's say, interpretation of the different architectural layers in the repository, and that's it. It didn't render visual diagram. Let me try, for example, to say, please render visual UML diagram for the core module. Let's see if it's able to deduct something. So again, it tries to give me plant UML representation. It's rendered line by line. It's a bit slower. Let's give it some seconds to see what it does. Okay, so again, it gives also some additional explanation of the relationships. Okay, gives us some additional explanations which we may not need. So again, we can refine our prompt to just get us the diagram. Here it gives a suggestion. So go to plant.uml online server, paste the UML code, plant.uml code that DeepSeek gave us, and click submit to render the diagram. But it didn't do it right away here. So I would say in that case, Claude did best in all of the cases. Now, this, what we've been seeing so far, is based on existing source code. But what about the case if we want to use any of these chatbots to do analysis of binaries? Is it possible? And the answer is yes. So, for example, for ChatGPT, we have different kinds of plugins, and two of the plugins we have are for Hydra and Radar 2. And these are really a nice example of how we can integrate a language model with an existing third-party tool. So what this plugin does, it allows us to upload a binary file or point to a binary file here. And ChatGPT invokes behind the scenes Hydra to decompile this binary, grabs the output, and does further analysis on the decompiled code. Here we have some examples for that. So I can use a prompt like, can you list all the functions in this file? This file is is a binary file in GitHub. Let's see if we can get it working. So typically binary analysis, as you might guess, needs some time. So on one side, this requires first for the large language model to invoke the tool to do the analysis, and then on the second iteration, the tool does the analysis of the decompiled code. While we wait here, I can show you also the integration for Radar 2. So here, this is the Radar 2 plugin for ChatGPT. What I'll do, I'll just try upload here a file from my machine. So let me go here. Let me upload. This is the same example file that we used for Hydra. And I'll additionally say, please analyze this binary file. Okay. Okay, so let's see what it does. It gives you a plan of what it's going to do. So it gives some information about the file format, about the entry points in the file, imports, exports, strings, and functions. Okay. Analyze. Okay, let's do that. Meantime, let's go back to the Hydra integration. So you see that these are the functions found in the file. Yes, it asks me whether I want to decompile the main function. And let's see if it gives me some meaningful explanation of what it does. The Radar 2 integration is still working. Let me just pause this in a. Okay. Please explain the main function. Let's see if that works. Let's go back to the to Hydra integration. So it gives me a decompiled main function. And as you can see, it's not only decompiled, but it also it's a relatively simple function that prints a hello world, expects us to insert a number, and then it does some comparison. So this is a simplified version of the main function as output by the large language model. And we also here, it gives us certain explanation of what this function is doing. So it's quite powerful. And you can imagine that for more complex binaries, it really simplifies the process of analysis. We can really analyze certain portions in a more simplified manner using the large language model. Okay, so here, what we get for Radar 2. Okay. Me to give you a current object in case you don't have R to install. Okay, so it asks me for some additional interaction in order to analyze the main function. I'm not going to go into those details, but as you can see, we also can analyze with the help of those tools and integration with the large language models, analyze very nicely binaries. And with that, if you have some questions, I think we can go in YouTube. So let's see. If you have some questions, you can ask them directly in YouTube chat. So let me go to the chat. Oh, yeah. Okay, so yeah, seems that we don't have chat right now, but if you have any questions, feel free to contact me in LinkedIn or social media and ask me about anything based on what I've just showed you. And with that, yeah, I would like to thank you for attending this talk. And again, if you're around in Auckland on 2nd of November, let's meet at ChairConf. There will be quite some interesting sessions from top speakers. And yeah, have a nice day, everyone. Thank you.